Okay, let's see an example on ANOVA One Way. You are being given directly the question, perform ANOVA for the following data at alpha is equal to 0.05 level of significance. Some values A, B, C are being given. On the this side, nothing else is given. If something like analyst and machine, like that, if something is being given, then it goes to ANOVA two way. Okay, since only A, B, C values are being given, ANOVA one way is what I will go with. Okay, first thing that I'll do is I'll go with the row sum and the column sum. Okay, so the row sum comes out here to be 95. And here it would be what? 115. And then here it would be 190. Okay, that would be row sum. Coming to the column sum, this would be 100. This would be 130. This would be 170. Okay, so if you just check 920. Okay, 0 will come. Okay, if you check the row and the column sum would turn out to be 400. Okay, this would be my grand total, guys. Grand total. Okay, so what will I do is first I will set H naught. I'll be setting H naught. What would be H naught? All variances are equal. Like that, I will set my H naught. What's the procedure that I'll follow is there's a table for ANOVA. I've done that in my previous video. Okay, how to find the values. Okay, coming to the solution part. First, I will set H naught and HA. What that is HA or H1. H naught is analysis of variances na. So I will say the variances are equal depending on the question. The variances of A, B, and C are equal. Okay, HA would be contradicting it. So, of course, I can take in variances or otherwise I can set like this. I'm sorry, I can set like this. Mu1 is equal to mu2 is equal to mu3 I will take. And HA would be mu1 not equal to mu2 not equal to mu3. Okay. Though I am doing analysis of variance, it is for the means of the samples only. Okay. So the ANOVA table for one way looks something like this. What are all the things that will be there in ANOVA is the factor term, factor, error, and total. Okay. Here I'll be having sum of squares, SS factor, SS error, SS total. DOF or DF is degrees of freedom. And then mean squares. MS factor, MS error, MS total I will calculate. Finally, F I will calculate. Okay. Yeah. So, coming to how will I find SS factor, SS error and all. SS factor, if you see, SS factor would be column total. Column total whole square by number of entries per column. Number of entries per column is what I'll be taking minus grand total whole squared by total sample size. Total sample size. I'll just show you what are all the things over here. Number of entries per each column, you see there are 3 entries. Okay, for each column there are 3 entries. Now coming to total sample size would be there are 3 rows and 3 columns. So 3 into 3 I'll be having 9. Okay, 9 will be the total entries or the total sample size. Okay, so what I'll be having here would be column total squared, column total 100, 130, 170 na. So here what I will take would be 100 squared plus 130 squared plus 170 squared by number of entries per column are 3. minus 400 squared by 9. Okay. You can just find out this value. It turns out to be 822.22. That will come here at SS factor. Okay. Now coming to SS total. SS total. The formula is nothing but I'll square the entries, all the entries, and sum them up. Same as this term only, grand total minus total sample size. Grand total whole square by sample size, the total sample size. Okay. So here summation x squared would be all. See here I'm adding all the columns and each column I'm squaring up. Here I'm squaring every element row wise or column wise, all those elements I'll be adding. 80 squared. This would anyways be 400 squared by 9. Okay. So this value, if you observe from the calculator, it turns out to be 2572.22. Okay. Now, how will I find out SS error? SS error. What's the error? How I'll find out it? It's nothing but SS total minus SS factor. Okay. So it is 2572.22 minus 822.22. Okay. That value I'll be getting it to be 1750 over SS error. What are all over? Just see here. All the first column entries are over. Now DOF is very simple. Degrees of freedom is very simple. How will I find degrees of freedom? It is just n minus 1, right? So degrees SS factor. For SS factor, the degrees of freedom is 3 minus 1. Okay. For error it is like yeah. For total it is 3 into 3, 9 minus 1. Okay. For error it would be 6. Okay. 7 minus 1, it is 6. Okay. Let's see how. Okay. Now coming to mean squared error. Mean squared, of course, mean squared factor, mean squared error, all those. Okay. Yeah. This is whatever I have got, that 6 is there now. How I have got, I will write, see here. This one. Okay. This is nothing but columns minus 1, guys. I'll write with a different color so that it's understandable, right? Columns minus 1. Now, coming to this, it is nothing but R into C minus 1. Rows into columns minus 1, this is. Okay, coming to this one, error always, here also I have seen total minus factor, na? So error also is total minus factor only. Total is what? 8. Okay, minus factor is what? 2. So I'll be getting it to be 6. Okay, 3 minus 1, this is 2. 9 minus 1, this is 8. Okay. I think it should be clear now. Now coming to the final column. Once I know the final column, I'm done. MS factor, I'll be calculating. It is nothing but SS factor by DF factor. Okay, MS error I'll be calculating. It is nothing but SS error by DF error. Okay. Yeah. So these values turn out to be 411.11 and this value turn out to be 291.67. The point that has to be noted, important point that has to be noted is always F ratio should be greater than 1, guys. Okay. So numerator should be greater than the denominator. Okay. Always numerator should be greater than the denominator. Or also my F formula, as I have discussed in the previous video, it is MS factor by MS error. Otherwise, MS error by MS factor, because always F value should be greater than 1. So 411.11 minus 291.67. This value, whatever it comes, I'll be taking 1.41. Now, F, just see whatever is the numerator, MS factor is the numerator, right? I'll take the degrees of freedom of MS factor. This is MS factor. And then degrees of freedom of error. Error I'll be taking 6. So tabulated value that I'll be considering would be, the tabulated value that we will consider would be F, just a second. I'll write, just carefully watch. Numerators, degrees of freedom. MS factor degrees of freedom is 2. MS error degrees of freedom is 6. Okay. MS factor and MS error degrees of freedom are 2, 6. Always mind this, guys. Take it properly. At 0.05 level of significance, I'll be considering. From the table, the value turns out to be 5.11. Now, if calculated is less than, this is the calculated value. I'll write it in short, FCal. FCal, if it is less than FTab, this is the tabulated value, FTab this is. Then we accept H naught. We accept H naught. Otherwise, reject. Otherwise, reject H naught. Okay. So, what is it that value I've got? FCal is 1.41, which is less than 5.11, that is equal to F tabulated value from the table. Hence, accept a H naught. What is H naught? All the means are same. Mu1 is equal to mu2 is equal to mu3. Okay, this is how I will do ANOVA. Okay, nothing to worry about. Whatever is the numerator, it has to be highest value has to be taken in the numerator and lowest value to be the denominator, because the basic idea for F is always that F is greater than 1. Okay. Yeah, I think it should be clear. Thank you.